Once again, we're back here to do part 3 of our Autodesk Inventor CAD training. So hopefully we can get through all the rest of the material in this part. And we're going to go through a number of different things. We're going to continue working on our hub and axle project. Recall last week, we built a hub. And I had mentioned to save your hub project, and so that we could then look at it again this week. So this was the hub that we made last week, and we're going to continue working on this project where this hub is going to be a part of it. So if you have that, you can open it. We're actually not going to really work on it directly right now, but having it nearby will be a good thing. So what we're going to do now is the next part of this project is to create an axle. We want to create an axle that this hub is going to fit on. So some of the specifications here indicate that the axle should be 24 inches long and has a 1-inch diameter. And remember, when we built the hub, we built a keyway into it. And in part 1, we were talking about how to lock the axle to the hub, and by use of something called a key that locks the two things together. Okay, so this is the other side of this key that we have to kind of cut into the axle and create a key that's going to lock it all together. Okay, so once again, the other side of this keyway should be the same size as the one on the hub, which is a 1/4 inch by a 1/4 inch. And the keyway should be at both ends of the axle and extend for 4 inches. So there's a couple of reasons as to why I made this as a requirement. One of which is this is a more accurate representation of what the real world would do. There would be no sense for a manufacturer to spend the extra time notching and putting a keyway in the entire axle when its purpose is simply to hold a hub onto it. They would have all kinds of extra expense and extra wear on their milling machines to cut keyway throughout the entire hardened, it's cold rolled steel. So they would only notch out the ends. So for realism, I wanted it to look as much as possible like what you would buy off the shelf. The other part of it is I'm going to show you a trick that can be used to do this. So, and then the axle should be steel blue. Okay, so that's fine. And then we chamfer the end. So you see the end here has a nice chamfer on it so that it doesn't cut your hands when you go and use it. So to start out, what we're going to do here is we're going to create a new part. So I'm going to go up to the top. I'm going to say new, and I'm going to pick to create a new part. And once again, given the requirements that I've been given here, they show that things are in inches. So what I'm going to do is I'm going to change my document settings and make my unit of measurement in inches instead of millimeters. Okay, so just by going into tools, then document settings, and then the units tab, switching the length from millimeters to inch and clicking OK. Now everything that I'm going to do here is going to have is going to be in inches. So first step is we're going to create a new sketch. Just like anything else, we start out our model with a plane, pick a plane to work on, and we start drawing a sketch. So I'm going to start out, it said a diameter of the axle should be 1 inch. So 1 inch, and we've got the diameter already done. Okay, so that's all finished. Now, if we wanted to, we could end this here and say, fine, that's what we want. And then 24 inches, we see the 24 inches here, 24 inches long, and we can extrude this and say 24 inches. Okay, and now we've got an axle that's 24 inches long, and that's great. Now, if we decided that we wanted to do the keyway right into this sketch, we could do that. We could take this circle and put this keyway in here. But if we put this keyway in here right now, and so it's in there, so I'm just going to rough do a real rough keyway here. I'm not going to dimension it or anything. I'm just going to very quickly put something in just to give an example here. If we have a keyway in there that looks something like that, and I say finish sketch, now what's happened is I extruded that, and now I have that through the entire model, which isn't what was required. What was required is to have 4 inches from each end. So in actual fact, when you thought you could put the keyway in on the original sketch, that's actually incorrect. You can't actually do that. It has to be a separate sketch. Okay, so I'm going to just hit Control Z a bunch of times here, and we're back to having our axle, a solid axle now. Now instead, what I need to do is I need to go into this face here and click on to create a new sketch. And now I want to create the keyway. So the key is 1/4 inch by 1/4 inch. So I can do, I can make a square 1/4 inch by 1/4 inch. And so that's great. That's all set the way it should be. And I can also now dimension this because I know it needs to be centered on the shaft. So I'm going to take this point here, this line here needs to be centered, or sorry, this line here needs to be centered across this. So I'm going to take this edge line and give it a dimension to go to the center of the axle. And to do this, I'm going to take this measurement here and say half of this is the center. Okay, so now I've positioned this square, so left and right, this thing doesn't move anymore. And up and down, it still does. So I need to figure out how I'm going to do that. And so we went into some pretty good detail on this on the hub for how to do the key. So I'm just going to, I'm not going to redo all of that conversation, but what I can do is I can do things like this. I can say, take this, and I'll often do this. Now, this is going to give me an error, which I'll explain, but this is another way that you can take measurements. So what I've done here is I've taken the dimension tool and I've pointed at this outside perimeter of this line. Now, this is basically the tool that I'm using here is saying I want to set the size of this, but the size of this has already been set in a different sketch and we've already extruded. So I can't really change it, right? So if I go and set this, and say, hey, I want to do this, it says, no, I can't create a dimension between the model edges. So it won't let me do that. Okay, so that's part of the issue why you can't do this. Okay, but what I can do is I can say project geometry and bring that in there, and then let's see if I can do this. Yes, so I bring in project geometry, which brings in that edge from the other sketch into this sketch. And it says, well, you can't set the size of it, but it does let you create a reference to it. So you see here, it's in brackets. And what that means is that this has been, you can't change it. It's a derived value from another sketch. So I can't change this, but what's cool is I can actually reference it though. So now what I can do here is if I say, I bring up this dimension for this line here and I click on this, you see it brings that dimension into here. So now 1 inch. So now I've got 1 inch from the center of this, and now I've inherited that. So now if I go into this other sketch here, so if I say, fine, that's what I'm going to do here. And then they say, they change it and they say, hey, no, that's actually a 3/4 inch shaft. Okay, and I do this. And then I go back into this sketch, you'll see that this measurement is now 3/4. It's not 1 inch. So because it's dependent upon another sketch and I've modified that sketch, those modifications are reflected in everything else that's dependent upon it inside of your project. Okay, so that's a nice way of doing it rather than just kind of saying, well, I know it's 1 inch, so I'm going to base it on that 1 inch measurement and do your math from there. No, it is 1 inch, but that 1 inch was determined by something else in a different sketch. And so we can kind of take a reference to it like that. So I'm going to undo this stuff here. And so I'm back to here. So now I have this sitting at 1 inch. Well, 1 inch brings me all the way up here. So if I want to bring the bottom of this square to here, I would do that reference divided by 2. And so now I have this edge sitting right here. But what I really want is the keyway to be halfway sunk into this axle. Okay, so really what I want to do is I want this to happen, which is great. But then I also want to subtract this measurement. And if I do that, it's going to drop the square all the way to the bottom here, which isn't what I want. So what I really want is I want half of that. So I can actually take this also divided by 2, and remembering to use bed mass through this stuff, using the brackets to do these calculations first and whatever. Although in this case, it probably wasn't needed, but just so that you know, it's going to mathematically evaluate things in the proper order. So now we have our square sitting there and in position, and it's completely locked in. Okay, so now what we can actually do now is we can start trimming out some of this if we wanted to. Before, when we were having this sketch and we wanted to just extrude it with the keyway in it, we needed to clear out some of these lines and trim them off, and then there was a whole bunch of work that we needed to do that. Because we're only cutting a keyway here, and we already have the axle already extruded, we don't need to do all that funky stuff, because what we can do here is we can actually go straight to extrude here now. And now if I take a look at this model here, what I can do is I can select this face, and now it says, okay, I'm going to extrude that 24 inches. It's like, no, I don't want it to build out. I want it to cut. Remember, so we have this direction here where we can say, I want it to go the other way. And then we also have this cut versus join. So I want this to, I can do one of two things. I can reverse the direction, and then Inventor knows automatically, oh, you mean cut. And if I do this, oh, you mean join. Or what I can do is I can say cut, and then it doesn't know what I'm talking about because nothing's actually cutting. So I have to give it a direction. So what I do is I just go all in one go, and just go reverse the direction. And then normally it would, I've messed around with it so much, but when it tries to optimize, it'll try and optimize to reduce the number of clicks that you need to do to actually achieve what you want to do. So now I've cut, and now it's cutting through 24 inches, but that's not what we want. We want it to be 4 inches. So I just changed this to 4, and now I've got my keyway cut, and now I'm all set. Okay, so now I've got that keyway sitting in the axle the way that I want. Now I could go to the second side and do the exact same steps that I just showed you, but instead I'm lazy. So what I'm going to do here is I'm going to project a geometry, and if you see here, I can actually see the edges of the other drawing that's on the other side of this. So I can say project this, project this, project this, and project that. Okay, so now this is actually the cutout now, and I can say finish, and now I can extrude. Sometimes this gets a little funky. So it gets a little weird here because what you'll see here is that because Inventor is confused, and the reason why it's confused is I haven't given it a clear identification as to where my cuts need to be. It sees this whole line and it sees this inside, so it's like, these things are all the same. So what I could do instead is I can actually right-click this, and I can say to make this a construction line instead, and then I can make this an arc here like this, and then lock it in on that construction line. Okay, so the construction lines, remember, don't actually identify things that are to be cut or extruded. They're references. Okay, so I converted that thing into a construction line, which doesn't end up making it something like extrudable, but then I added an arc onto here and I locked it to reference the construction line. So now it's fully constrained. And then, of course, because this is projected geometry from the other part of the model, this is also fully constrained. So now I have a fully constrained sketch here, and I can say okay to that. And now I can do my extrude. Okay. Once again, it's coming out thinking I want to build something out like that, which I don't. I want to push it in. And when I do that, it's going to say, oh, then you mean cut. So watch this. This will change from join to cut here once I do this. Okay. So now I have it. So now I've got my keyway all done and my axle pretty close to what this is saying. The next thing it tells me to do is to change the color to be steel and blue. So I'm going to go down into our colors here and look at steel blue. And so there's our steel blue. And then the last thing is to chamfer the ends by 0.125. So I'm going to select our chamfer tool, and it's already defaulting to 1.125. I chamfer there, and I chamfer out there, and now I'm all set. Okay, so now I have an axle that looks just like the one that they asked me to create. Okay, if I hit home here, this view is actually going to kind of put it in whatever orientation according to the planes that I started drawing on. If you want it to actually be something that kind of shows the part a little nicer or whatever, maybe if you're doing a video and you want to have a nice thumbnail or something, I don't know. What you can do is you can change this so that this becomes home. So I can actually set the current view as home, and I'll say fit to view. So now I can say, go to the right, and I can say home or something, and now it'll bring me that view and bring it to home like I said it was supposed to be, with a nice view of the keyway and this shaft diagonal, and a fit to view, so it'll make it as big as possible into this viewport that I have. So that's it for the axle. So at this point, I'm going to press Control S, and I am going to save this next to my other thing, my hub, and I'm going to name it axle. Okay. So now that we've got that done, the next step is we need to make a key. Now, the key is super easy. It's basically just like a square that's been extruded to 1.5 inches. Okay, so that's really easy. So let's do that. Kind of seems sort of funny to make that your final part that you're going to make, because it should build up in complexity, right? But no. So I'm going to make my square. So I know that the key, it doesn't tell me here, but I know that in everything else that we've been doing, the key is a 1/4 inch. Oh, okay. So this quarter here, notice this. So I'm actually in millimeters here. So I forgot to change my units. So I'm going to go up to Tools, go to Document Settings, go over to the Units tab, and change this to inch, and then say OK. So now what this has done is it says this is actually going to be, keep it as 1 millimeter, but now I'm going to redo it and say this is going to be a 1/4 inch, and now we're at a 1/4 inch. And once again, the height in this direction needs to also be a 1/4 inch. Okay, so now I have a square. It's kind of floating out in nowhere, so I'm actually going to grab this point in here, and I'm going to anchor it to there. So now I have a locked, fully constrained square sitting in a sketch. Say OK to finish that sketch, and I'm going to extrude it, and it wants me to make it 1.5 inches. So it's 1.5 inches. Okay, so there's a key, and make the part iron gray. So let's go in here and iron gray. Okay, so there's my key. So now I'm going to hit Control S and say key. All right, so now I've got 3 parts. I've got a hub, I've got an axle, and I've got a key. So the next part is to try and put all these things together. Okay, so to do that, we're going to create a new kind of document. The kind of document we're actually going to create here is something called an assembly. So you can click on File, New, and then this dialog will show up, and you can pick Assembly out of here, or you can use this pull down up here and pick Assembly there. Either way, doesn't matter. So in this case, what we can actually do is we can start putting our pieces together. Okay, so what you can do is bring in some of your models that you've done. And so in this case, what I'm going to do is I'm going to go to, I'm going to grab my key and bring that in. Okay, so now I've brought this into my assembly. So now I can play with this key and do different things with it. I can make multiple copies of it by Control-C and Control-V. And I can delete parts. I can do all that kind of stuff. And what I'm going to do here now is I'm actually going to bring in the hub as well as the axle. Okay, and you can actually multi-select the you can multi-select files in this dialog. So you see I got hub and axle both selected there. And if you zoom out a little, you can see that I've now just placed 2 parts. So you can select multiple parts at the same time. Okay, so now I've got this one here. I actually want to have 2 of these. So I can right click it. I said Control-C and Control-V before, or you can use the right click menu to say copy and then paste to actually give that to you. So now I've got 2 hubs and a key. Oh, I need a second key for this. So I'm going to say copy this key and then paste this key. Okay, so now I've got 2 keys, 2 hubs, and a single axle. It's starting to look like something. Now, in order to construct these things, right now they're kind of, you know, all over the place, and it's really hard to actually kind of tell, you know, in 3D space, how close are these things to each other. And this is where you really need to understand the view area that you have. If I say do this, you would think that that axle would be coming through that hub. But in actual fact, if I change my view here, you can see the reason why it's not coming through is because I'm beside it. Now, if I do something like this and then go into home like this, now you can see that I'm actually above it. So now if I come and bring that down and then go into 3D, and then now I do this, you'll start to see the hub coming through, or the axle coming through the hub. Okay, you don't need to do all that. You don't need to get it, you know, lined up like this in order to build it. I'm going to show you how you can do this much easier by using things called a constraint. Okay, so a constraint dialog, this is going to be your most common dialog that you're going to use inside of an assembly. There is units of measurement within an assembly as well. So if you have some offsets or things like that that you want to include, which we will a little bit later, we need to go back into tools here because this is a new document, and go into document settings and go to the units tab and make sure that inches is selected here as our unit of measurement, which it is. Okay, so our next thing is to hit this constraint, and you can see that it's going to try and highlight different facets of the models. And the things that I'm interested in doing for this constraint is I want to line up the axle to the hub. And so to do that, I can come in here and I can hover over this circle. And you see, as I hover over this kind of cylindrical hole here, you see that there is a center line. So like a line dot, that actually is a draftsman notation for center line. So I hit that and I've got the center line, and then I want to take up the center line from the axle. Okay, so I hover over the axle. I could do it off of any one of these things, but here, like here, I can pick it up off the chamfer. I can pick it up off the cylinder itself. I'm going to pick it up off the cylinder itself. So So I picked that up, and now what's happened is I've created a constraint. So I clicked OK, and so now no matter what I do, I can move this whole thing around and do whatever I want. I can move this, I can try and move this, but no matter what, it's going to keep to make sure that those center lines are always locked together. So it doesn't matter if I go here and try and go left, right, it's going to move all of it together. If I try and go here and move this, it's still going to be on there. Okay. So I've basically created this constraint so that it's locked. It won't come off of there. So what I also want to do is I don't want this sort of stuff to happen, right? So I want to be able to set this so that it comes out just the right amount. And you don't usually, when you build these, you don't have them so that they're flush. You usually have these so that they're kind of sitting out a little bit. And so to do this, what you can do is you can place a constraint and say this surface of this edge here and this surface here, I can make them flush to each other. Okay. This one here is a mate, which means it flipped the axle around and said this face here needed to mate against the end of the axle, which isn't really what I want. What I want them to be is flush. So now it switched the axle back around again, and now the axle goes all the way through here. Okay, so now this level and this level are now flush. So if I go like this and flip this, you'll see that they are totally flush with each other, and I can't move them because it's thinking that that's got to be flush. I don't really want them completely flush. I want them slightly offset, and I'm going to offset them by 0.125. Now you notice what that did is that sunk it in. So it actually went in as the offset. So instead I need to reverse that. So I'm going to make that negative and say it's 0.125. So now it's actually kind of sticking out, which is kind of what I want. Okay, so now I've set a constraint between those two surfaces. Now, no matter what I do, those things are going to be mated together. It's not going to fall off the end. It's not going to slide down the axle any further. It's locked into position. I actually want this not to move around as much as it is. So what I'm going to actually do here is I want to make this axle be fixed in space so that when I move things, the axle is not moving all over the place too. So I'm actually going to right click this and then select this to be grounded. Okay, so I ground that. And now as I hover over it, you can see, I don't know how many people are familiar with electronics, but the little pin, and there's a ground symbol there for electronics. It's the ground symbol. So now if I try and move this, it won't move. This won't move off of the position where it is because of the constraint holding these two faces locked together. It won't come off sideways off the axle. It's locked axially through this, but I can spin it, which probably isn't what I want. Okay, so this is where the key comes into play. So now this little guy here is actually going to lock all these things together. Okay, so to do that, I can try and position this into a spot that I can kind of visualize how it's going to work. And so what I'm going to do is I'm going to pick my constraint tool and I'm going to use mate. So I want to mate this surface and I'm going to mate it to the bottom of the keyway. So now I've got that mated there. So I can say okay to that. And now you can see it looks like I'm actually moving this off of where it was supposed to be, but that's just an illusion. See, I can't move this up and down. It's actually going right through that spot. Okay, so that's exactly what I want. It's coming through. Like I said, it looks weird, but trust me, it's doing the right thing. And so now what I can do is I can take a constraint again, and this surface right here, so the inside of this axle, or I can do the inside of this hub. It doesn't matter which one I'm going to choose here because I'm going to do both of them eventually. So I'm going to pick this here, so that surface there, and I'm going to pick one of the surfaces for the key and apply that. So now what I've done is I have locked this key to the axle right in the keyway. Okay, I don't want the key to be sitting out here, and I also don't want it to be sitting here because I think that might catch somebody's hand. So ideally, I'd like this to be recessed into there or maybe flush with this hub. So what I'm going to do now is I'll take this surface of the key and this hub face and say make them flush and say okay. So now it's now flush with the hub, but this is still spinning free because I haven't made a constraint on there. Okay, but that's easily remedied. I can take the constraint tool here and create another mate constraint and say grab this face here. Oh, sorry, the other one. Grab this face here on the hub and then bring this around so that you can see what should I do here? I can't remember which one I did here. So I took that face. Oh yeah. And so now I want to get onto the keyway here. Okay, so this keyway edge is where I want that to actually mate to. Okay, so I've taken those two faces and I've mated them together. And now I say, okay. Okay, so now everything's locked. I can't move anything. Okay, I have fully constrained this part, so now it can't move. The axle is grounded and the key is locked in to the axle. The hub is locked to the key. The hub is constrained to the axle and all that. So everything here has been locked together. So that's just using those constraints. There are some times when you want to, be able to have some flexibility and things like that. And you can actually expand and suppress some of these constraints here. So in the side here, you see all these different parts that we've included. We've got this hub and we've got this key, and you'll see that these things, we can actually go up and say, we can edit, say this one, this flush one. Say I didn't like the 0.125 and I actually want it to be 0.25. I want that to be, yeah, that's right. I wanted it to be 0.25. Okay, so I can edit that constraint inside of there just by right-clicking and saying edit, and then changing the amount that's in there. But I'm going to put it back. All right, so this is everything here. What you can also do is you can choose to suppress. So if you want to play with something and kind of see how it fits, otherwise what you can do is you can actually suppress one of the constraints, so it will no longer be applied to the assembly. So now at this point, I suppressed one of the constraints, so now I can actually move this key around. Okay, so if I wanted to temporarily do something like that, I could just suppress it and then click it again to actually enforce it again. This other hub I need to get lined up into here. So there you can see that it's kind of misoriented. Now I can easily do this by just saying take this surface here and the axle surface here and make them flush to each other, and then you can see that it just flipped that hub the way I wanted it to be. I'm going to show you another way that you can do that, because that's a pretty easy way, and that's actually the way I normally would do it. But there may come a time when you actually need to manually orient a part in order to get it in a position where it's more easily constrainable. And to do something like that, what you can do is you can use this free rotate, and this free rotate places kind of looks like crosshairs around a part. I can actually select a different part, and it won't let me do a free rotate on something that's locked. But if I do a free rotate on something like that. So if you click and drag on the inner circle, it'll actually rotate the part like that on kind of an axis. And then if you are outside and you click and hold and drag, you can see it spins on a different axis. See that? So I kind of have two different ways that I could change the orientation here. In this case, I want this to kind of get it to be sort of lined up, at least close to what I want. And then I can click away and to disable the tool, or hit escape to get out of the tool. And now I can visualize this better. And so once again, I'm going to do those constraints just like I did before. So hit the constraints, and notice the dialogues for constraints show up and look just like some of the other dialogues in Inventor, where it has sort of the different operations, and it's prompting you to kind of click surfaces and things like that. So some other constraints that you can apply here is, for example, this isn't what I really want to do here, but what I'm going to show you is I can use, say, an angle constraint. And there are different kinds of angles, and these little buttons here are showing you the different requirements for each one of the angles. So if I'm going, this one here is a reference via a vector. So if I have three angles that need to be considered during this constraint, then this is the bit that I need to do, like in 3D space. If they're all across the same plane, but just fanning out, I can use this undirected one. Usually I end up using the directed angle, which is simply two faces. So if I select this, you can see it disables the last item here, and I can now select two. So in this case, what I'm going to do here is I'm going to take, say, this face here and this face here, and I'm going to say, because what it just did is it moved them so that they are at 0 degrees to each other. So instead, what I'm going to say is I want them to be 90 degrees to each other. Okay, so now this surface here is 90 degrees to this surface here. Again, this isn't something that I'd want to do in this particular use case, but I'm just showing you, the different kinds of constraints that you can end up using, which may be useful in your work. So what I'm going to do now is I'm actually going to kind of put together all of the constraints that we went over already. I'm going to use this circular axial constraint here and this axial constraint and put them together. Okay, and that's done. And I can just click apply, and I can keep applying constraints and never leaving this dialog. I can actually now do this and this and say 0.125, and it needs to be negative 0.125, and say apply. And now I can grab this key here, and I can say this surface needs to be onto this surface and mated. So there's that. Now I kind of need to reposition to kind of get a good view at some of these, to be able to click on some of these things, because now it's kind of placed it in such a way that I can't get at some of the faces that I want real clearly. So I'll close this dialog and I kind of move things around so I can tell what it is that I'm clicking on. So far I've got a constraint that is sitting lined up here, but it needs to be lined up onto that. Okay, so now I'm going to take this and I'm going to grab this bottom face here and then turn this and mate it to that there. Okay, so now I've got the key into position, and now it's locked all that stuff together, but I have to mate this yet, okay, because that's still moving in and out. So now to do that, I can take this face here and say, make it flush to this face here and say, okay, and that's it. Okay, so by the end, everything here is all locked together. The key is locked, the hubs are locked into place, everything is all assembled and together. So there we have it. We've made some models from scratch and created an assembly that incorporated all of those models and been able to construct something that is recognizable and something that we could eventually start to build into the robot. The other thing that you can do here is that I can save this now. So I'm going to save this as, say, together. And what I can do is I can now create, say, a new assembly. And I can say place and grab together as an assembly. Okay, so this whole assembly is here. And I'm going to do that assembly twice. Okay, so I can bring assemblies into assemblies. Okay, so now if I was doing this and I was making a go-kart or something like that, I could actually bring in two of these things, identical things together, and then bring them into another assembly and put together a whole drivetrain, and then save that assembly as a drivetrain, and then bring that in to another assembly that is for the body. Okay, and so if I want to get into these assemblies, I can actually double click, and then it opens that assembly, and I can make modifications to this assembly, and it'll be replicated in both of these. So if I go into here and I change this, let's see, something that's kind of handy too, I'll show you in a minute here, is I can actually show constraints or show relationships, and it'll actually show you all the different relationships. And then as you hover over them, it highlights them in the sidebar there. Okay, so that's kind of a handy way. You can see that this is actually a flush here. And this here, if I go over this, so then you can see the keyway and how that is a mate in between there. So you can actually see all of those different relationships. So I'm going to hide those relationships again. And what I'm going to do is I'm going to modify this, our favorite little one here, and say that this is going to be minus an inch. Okay, so now I do that, and now if I flip back, now notice I haven't saved anything in here. I haven't saved this file since making this change. If I go into here, it's already updated these assemblies with those changes. I haven't had to reload, save, do all that kind of stuff. It knows that those are the things that reference, and those are the things that are open right now. So now if I go Control Z and this goes back, and then I flip back to this assembly, they're back the way they were there as well. Okay, now it does some interesting things here. If I close this, so I'm going to save this and then close this, and I'm going to close each one of these parts down below here so that they're no longer open, and I'm going to double click that assembly. If I don't have it open, it's going to open it in place here. Okay. Or what I can do is, and so if I open it in place, now I'm actually inside that assembly, inside of this assembly. A little bit of a mind warp, but I can actually play with all those things right inside of here, even though overall I'm in that bigger assembly. And when I'm done making my changes, I go back up here, and then I'll be back into the overall assembly again. Okay, it takes some getting used to and kind of wrapping your mind around, but it does become pretty handy. If you do want to open the assembly all on its own, you can right click it and say open, and that'll open up that part right within its own tab at the bottom. I can say open this assembly, and it opens that assembly into its own tab. You can actually do work on parts here. So if I now, if I double click this, and I'm in that assembly now, and then I right click this, actually, I'm going to double click this, and now I'm actually into this part. Okay. And so now I see how this has all happened. I've got two together assemblies, and inside that one together assembly, there's a hub, and inside of that hub are all the different sketches and details that I have done, including this one that has, way back when in our first part, the spots for where the bolts are going to protrude. So I can go in here and now edit this pattern and say, I want this to be a 6-bolt instead of a 5-bolt. Change that, say finish that sketch. The well, something didn't quite work the way I wanted it there. Let me take a look here. What did I change here? Six, 360. Oh, I see. Okay, yeah. So because I changed the number of holes here, I also have to change the extrusion because the extrusion doesn't know that I added a new hole. So I go into the extrusion and I select profile, and then I select this additional hole and add that hole. And now that's done. Then I click return to get out of this part, and I can click return again to get out of this assembly. And now both assemblies have been updated, and I now have a 6-bolt hub completely propagated from one of my base models, my very first sketch that I made, into this whole project. And it's percolated all the way up to our final assembly. I couldn't do those types of things unless I was doing referencing and I was thinking about, how I was going to design this part overall. And that's why making references and calculated things and projecting geometry, all those things are important, because then you can have this sort of cascading effect of changes propagating its way throughout all the way to the final assembly. So that pretty well covers all the things to get you started. It's not everything inside of CAD, but it certainly is enough to get you started and enough for you to kind of understand how the tools work. And then, Googling and using YouTube for some specific use cases for what you need to do. They'll walk you through some of that stuff, but they may go at a pace that is a little faster than what you need if you'd never seen it before. But now that you've seen a lot of these things, I'm hoping that those tutorials there can make a lot more sense. So that is the end of this part.